Hi, I am Christopher Murillo. Today we'll talk about EM signal filter. As a first point we have what is a band pass filter. A band pass filter's secure device is used to allow only a predefined set of frequency to pass through it. It's a combination of a high pass filter and a low pass filter. A filter that allow only the frequencies that higher than it called as a high pass filters and filters that allow the frequency that are only lower than it is called a low pass filter. What is active low pass filters? By combining a basic RC low pass filters circuit with an operational amplifier, we can create a complete active low pass filter circuit with amplification. Active filters contain active components such as operational amplifiers, transistors within their circuit design. They extract their energy from an external energy sources and use it to increase or amplify the output signal. On the other hand, a low-pass filter is a circuit that can be designed to modify, reshape or raise at unweighted high frequencies of an electrical signal and accept or pass only those signals decided by the circuit designers. Passive filters are composite of passive components such as resistors, capacitors, and inductors and do not have amplifier elements, transistors, operational amplifiers, etc. So they have no signal gain. Therefore, their output level is always lower than the input. Now, I will talk about high-pass filters. High-pass filters are classified into active high-pass filters and passive high-pass filters. And active high-pass filters can be created by combining a passive RC filters network with an operational amplifier to process and high-pass filters with amplification. The basic operation of an active high-pass filter is the same as for its equivalent RC, passive high-pass filter circuit, except this time the circuit as an operational amplifier or included within its design providing amplification and gain control. Passive high-pass filters. A high-pass filter is the exact opposite to the low-pass filters circuit as the two components have been interchanged when the filter's output signal now being taken for cross the resistors, whereas the low-pass filters only allow signals to the pass below its cutoff frequency point. The passive high-pass filter circuit, as the name implies, only passes signals above the selected cutoff point, eliminating a low frequency signal from the waveform, whereas the low-pass filters only allow a signal to the pass below its cutoff frequency point. The passive high-pass filter circuit, as the name implies, only pays signals above the selected cutoff point, eliminating any low-frequency signal from the waveform. Consider the circuit below.
Selectivity of a filter. It has three options: Q factor, filter order, and selectivity of receivers. Q factor. It measures the relationship between the reactive energy that is stored and the energy that dissipates during a complete cycle of the signal. It is denoted by this Q equation, and the range of frequency to which in the system responds significant is the bandwidth, and the central frequency is the frequency of the electrical resonance. Then we have the filter order, degree of acceptance or rejection of frequency above or below the respective cutoff frequency. Order is equal to 2 multiply n variable. And we have the acoustic wave filters have been so popular at the frequency below 2 GHz. And finally, we have the selectivity of receivers. These are receivers' ability to discriminate between signals having different frequencies. Ability to deliver Available filters that can strongly influence the architecture of the receiver. And finally, is a high selectivity near the antenna can be significantly simplified. Downstream, the modulation electronics. The quality factor of a filter. The Q factor is a measure that determines how selective or non-selective is the bandpass filter around a given extension of frequency. As long as the Q factor is smaller, there will be greater bandwidth of the filter. In consequence, if the Q factor is larger, the filter is narrow and selective. The quality factor receives the Greek symbol of alpha and is known as the alpha peak frequency, denoted by the following expression: alpha equal 1 over the Q factor. The Q of a bandpass filter is the ratio of the resonant frequency to the band between the upper and lower -3 decibels frequencies. The Q is denoted by the following expression: Q equal resonant frequency over bandwidth. For example, if we have a resonant frequency of 346 Hz and a value of 400 Hz, the Q factor will be 0.865 and the quality factor will be 1.15.